Hello everyone, welcome to our Capstone presentation. We will be talking about fairness and recommender systems, and we will introduce to you the general concept, our research, and our objectives for this project. So let's get into it.
Good afternoon. As you've already heard, our Capstone project will be on fairness and recommender systems, specifically focusing on the mitigation of minority biases. Large corporations invest millions of dollars each year into advanced algorithms to recommend products to consumers such as you and me. These large corporations aim to please shareholders and also to capture the majority of the market share of the consumers. This might mean that more popular products will be pushed to the general public, and as a result, someone of a minority group might feel that this product is not a good fit for them, and they're questioning why that they are being recommended these products. And that question that they're posing is actually very true because there's actually a very strong bias towards minorities within these algorithms. Minority groups are underrepresented in these algorithms, and there is definitely a bias there to please the overall public. And the goal of our paper and our Capstone project will be to implement different methods and strategies combined to determine what the best approach will be for mitigating this bias. So some of the strategies that we have already seen are adapted value-aware ranking and enhanced re-ranking procedures. We have also seen pre and post processing strategies, which have been determined to mitigate bias. Or for the goal of our paper, we would like to examine these past procedures and strategies that have already been implemented and to create our own strategy or method and then test this on one of the data sets in either addressing bias in product recommendations or exploring author gender in book rating and recommendations.
As for now, our team has found 5 different approaches in order to achieve algorithmic fairness within the product recommendation system. The first one was proposed by Ree, and he proposes to counter it by regulating the recommendation score differences. This approach was found to reduce popularity bias significantly while maintaining the accuracy. The second method is called enhanced re-ranking procedure, and this proposed method for counteracting popularity bias during the aggregation process and refining the group recommendation. This method was also found as to reduce popularity bias significantly while maintaining the accuracy. The next method was proposed by Mitsuradeka, and it identifies clusters of users whose needs are not met by a recommendation algorithm, then isolates the main attributes that characterizes those users. The next method was proposed by Ashokan and Haas, and their approach adjusts the predicted scores from the learned differences between privileged and unprivileged groups after training a recommender system. And there are many benefits of these methods. First one is the algorithm is self-content, it doesn't need to be adjusted, and second, it has strong compatibility as its effectiveness doesn't rely on the quantitative fairness metric definition. And the next method is proposed by Deju, and he proposes a probability framework based on generalized cross-entropy, which produces a measure of unfairness by analyzing divergence from what is called fair in this system. While achieving fairness, we face 2 challenges. First one is privacy, for example, a discriminated group based on the gender. And the second challenge is to define fairness model for the algorithm itself, to select a metric carefully and that actually corresponds to what one is aiming to change and to identify as a fair.
All right, now for looking at our objectives, we will work on a data set which we have seen in some of the papers that in one of the papers that we have seen in our during our research. The 2 options we have are either looking at a paper about marketing bias and product recommendations or a paper about book rating and recommendations. Both of them are relevant and related. They're both recommendation algorithms, just looking at different things. And what we plan on doing is to expand on the research already done in the paper we end up choosing by either considering another type of bias and implementing it in addition to what has already been done in the paper, or implementing a different bias mitigation algorithm, like a different strategy, and comparing the results in terms of fairness. So those are our objectives for this project, to expand on the research already done in one of those papers and see how we can further reduce bias.